Okay, welcome everyone to the 12th Kids Knowledge Seekers Workshop, brought to you by the Keshe Foundation Spaceship Institute. And today we'll be speaking with Mr. Keshe of the Spaceship Institute at the new location in Bari, I've been told, Italy. And um, we'll be having probably a shorter program today, and things have been a little pushed on for our schedule. And so we'll get right in. Maybe we'll hear from Kevin Devaney now and see what he has to say, what his comments on today's kids workshop. Kevin, are you there?
Hi, Rick. Hello to Mr. Keshe and all the knowledge seekers. Let me just summarize what I learned, or what I learned personally from last time. You made the drawings in a really beautiful way and showed us how to create environmental conditions, uh, the magnetic or gravitational field strengths to attract the CO2 and produce the CO2 Gans in a salt water solution with a zinc plate and a nano-coated copper plate. Now, we've been all taught in physics or whatever school physics, and I do hope that in the very near future that more and more young students, teenagers, kids do listen to these workshops, or they get taught at school the things that we've been hearing and understanding up to now. So what I want to go into detail now, what I would like to ask you to explain to us, or maybe with an additional drawing, where I told Rick, we're trying to get up to set up some kind of non-copyrighted material. I think it should be taken for granted to use any material if it's educational purposes. But for the sake of it, Ed Schumann, one of the really brilliant animation maker, he sent me a drawing. I sent it to Rick, so maybe you can post it or upload it. To make especially kids or younger adults or even younger students understand this nano layering and where the magnetic or gravitational field strength, the plasma energy, is actually well, if I can say that, preserved within, correct me if I'm wrong, within the gaps of the atomic structures of those nano layers within the GANs. Could you correct me on that, or add to that? Thank you very much.
Can you explain more in a very simple way that I can understand how you want me to explain it?
Okay, I would
Read your
like.
question in a very simple way.
Sure. I myself, and I want other kids to understand or to imagine what these nano layerings look like, and why is this such a compressed energy within the GANs, and how is the fields, these magnetic gravitational fields you always talk about, where are those uh, uh, embedded, or where are they within those layers? How can I imagine that, or how can kids imagine that?
Don't imagine. I think it's better not to imagine, but it's better to understand. Um,
You can see
if you're a
Ad's
young,
picture
you
there
no,
on
I
the
don't see
side.
it on. I've got a.
Okay,
No, I'm not
you won't be able to
going.
see. Okay.
I cannot see the
Um,
what you
Let me
picture.
describe it briefly. I'm not sure if it fits in with what you're going to say. It just shows a single GANs, and then it shows it as multiple GANs, and then they all conglomerate together, and more of these GANs together to form the nano layer, basically, in sort of a flower of life pattern. That's basically how I can explain it. But go ahead with what you're going to explain, Mr. Keshe.
Um, the simplest explanation for children to understand, I think, is them um, going back to how what they can experience physically. And I think what children can experience, then they can translate it to a simpler language of understanding. In a way, it's like when you stand in a schoolyard, in line, next to each other, and the teacher tells you to open your arm. And you have to stand next to your friend, arm length that the tip of your fingers touches. That's your space. That space from finger to finger, that's your plasma. But you have the same number of friends in front of you, and they have the same number of friends behind you. And they are standing in the same way, that if you rotate next to the friend in front of you and the one behind you, now you have the same gap between tip of the fingers. This circle of your arms is your space, this is your plasma. And the friends who are standing next to you in line, that line of friends and the gap between your body and their body, arm length, you have 1 nano layer. Nano means singularity, and why we use the name nano, the term nano, it means 10 to the minus 9. That's where the terminology comes, nano layer. Because we say 1 atomic hydrogen, you need 10 with 90 in front of it to be able to put together to make 1 meter. That's million by million by million people arm next to each other. That's when you put that many people and you can make it to 1 meter, then that's 1 nano. 1 single, you are 1 nano out of that 10 million next to each other. 10 to the power of 9 with 9 zeros. So you are with your friends which are arm to arm with you, 1 line, this is 1 nano, 1 single line. Then you have your friends in front of you with the same span of arm. They are 1 layer themselves because they're in 1 line. That's why we call layer. Layer means 1 line, 1 sheet, in 1 uniformity in the spread. So you have friends in front of you with the arms open, you have friends behind you with the arms open distance from each other, but in parallel line to line. So now each one of you is 1 layer. But don't forget that you have a friend in front of you which is arm tip, and with your tip of your fingers is again in this equal distance. So now the gap between your friend on the right or left or the front or the back is exactly the same. So in these gaps between you, anybody can run because it's a huge gap. When your arm is not in line with your friends, with the gap between the layers in parallel, so anybody can run between you because there is no resistance. This is what we call superconductivity, no resistance flow. So the guy who runs amongst you runs without any resistance. If you turn and put your arms in respective fingers with the guy in front of you and the one who was behind you, and you get the same guy running, he has to hit every single arm to be able to go through. This is a matter state. When you have your arms open and the guy can run all the way through without resistance, this is what we call superconductivity. And that gap between you and your friend in front, which is no arms, but it's a fixed gap, this is where the energy sits. Then you have to realize if you start getting closer, bending your arms in till the arm comes next to each other and you come next to your friend, shoulder to shoulder, then it's the same energy which you have, but now there is no gap. And then if the friends from the back and the front come and join you, in a way, come in line, you still keep your lines, but now you have no say in the movement. The movement is totality. Every single one of you which is pushing is spreading the energy all the way along the lines in both directions, front, the back and the side. This is the easiest way to explain nanolayers and the behavior of nanolayers. You close the gap, the energy gets concentrated, you become a matter. You open the gap, you have a freedom to run, freedom to move in any direction, then this is what we call nanolayers, the property of nanomaterials. Where does the energy come from? When you had your arms open and then you put on your side, the gap is there. You don't feel the energy of your friend who's standing his arm length away from your arm length. But as you bring them together, as your friends come together, you feel all the energies from everywhere coming in. Nobody has changed. None of you is pushing, but you're closing the gap. And now you feel each other's warmth and the energy. And it's like very much you go to concerts. When you go to concerts, there's rows and rows of people. And they're all standing there, but they start pushing. At the beginning, there's nothing, but when the push comes closer and closer, you start moving forward. This is the property of matter. When your arm was the size of your plasma, when you reduce the size of the plasma, you have to accept the fields of others, the energy of the others, because now they dictate as part of you, as you dictate their position, their energy. Where does the energy come from that you suddenly start feeling it? All these energies are inside you, inside them. They don't tank and come closer, they don't drink energy and come closer. It's the same as a plasma. The energy of the plasma is inside it. Depends how you position it in respect to the others, is how you feel their forces and how you allow other things to go through you and amongst you. So, you see yourself as a plasma. If you put the dots on top of each one of you, if you go from the top, you just put where the head is one dot, and then the arm gap distance between the two, another dot on the top of the head of your friend on left and right. Those dots are the center of the plasma. And the gap between them, between your friend's head and top of your head's friend, and top of you and the other friend in the front of the back, this becomes the positioning. The amount that you have the freedom to move without touching them, without them blocking you. This is
Showing a picture by any chance, or okay?
no,
Just want
no,
to be
no,
clear
no.
on that. I thought
The
you might
thing
have been
is, we
making
don't.
some stick men there.
Maybe it's a good idea. I'm getting old and forgetful, but because we don't have our pens with us, we forgot to bring the pens from where we came. Can you see the picture? You see, this is. I tried to make a circle. Yeah. So it's coming up.
It's coming through there now, I think. Anytime. There we go.
Is it coming up? There we go. Okay, so let's do it with drawings. I think it'll be easier. What you have, we still, yes, okay. We say this is the, I'm gonna go on the Skype because they're not see it live. on the thing is a delay on the live stream. So this is you with your arm open from two friends. This is your friends standing there on either left and right. And the same another friend with their arm length. You have the same arm length from the friend in front and back of you. The same, there is another friend here which is doing the same. You are, if you rotate this way, you have a gap. If you rotate that way, this is the gap between you and your friends. These are your arm length. This is another friend, arm length, two arm length. So what happens? These are your tip of fingers. So this is your arm length, and here, this is your arm length from your friends. So you have this position. The friends in front of you are arm length from each other. The friends in the back are arm length from each other. So you are in a row. This is the row. And there is another row of your friends there, another row there. So now we call this row one layer. In terminology, in the electronic or in the material, we call it a layer. So it's layers of you. Layer 1, layer 2, layer 3. But when the distance between your friends and you is 10 to the minus 9, or you put 1 with 0009 of it in the background, 2, 4, 6, 8, 9, then this is the size of one atomic hydrogen. And the gap is 1 nano. So now, in your friends, if you could be that small, you become a nano layer. But if you put the same thing at top of your heads, now we don't need to put the lines. We put you next to each other. Just 1 second. I have to respond with this, please. What happens now is all your friends next to each other. So now you make 1 nano layer. And the gap between you is the same. Now your arms are not sticking out. So any friend can run in between you in any direction. There is no resistance. This is the state of a plasma. So now this is the top of your head, and no gap, no matter to stop the flow. This is how now your head becomes a plasma, a center of a plasma, where the energy is. You carry energy, your friend carries energy, and so now you have become a plasma in the environment of your friends, because these are your energies and the gaps between them. Now, if you bring your friends closer, as we explained, it's the same plasma. Your friend hasn't eaten any more food or nobody's pushing it. But as you close a gap, you transfer till the point where you two touch. Now, you have every...
Oops, we just lost your audio there, Mr. Keshe. Okay, we're just restarting on some of the on the Skype here. See if we can get the Keshe Spaceship Institute back online. This is where we need to get Kevin playing his guitar and singing a little song as an interlude.
Cannot play any instruments, I'm sorry.
Well, it's a great time to learn then.
Yeah.
Put you on the spot, and that's the way. It's the instant learning technique.
Mm.
I got my son a ukulele. I could probably go string a couple of chords that way.
there you go. That would be perfect for the child's workshop. Let him rip.
Yeah, where the
Give him a slide guitar and let him rip. Okay,
So
there it
what it
goes.
sounds like
The
is that
Spaceship
the Spaceship Institute was just on their phone, and when they got the call, it got knocked off the Skype. So they should be.
Right. I'll try to re-invite them back in here.
Hello, we are back.
Hello, welcome back.
How did you kick us out?
I think it was your call maybe that came through and interrupted somehow. I'm not sure about that.
Okay, so we are back in. At least we are still alive and we are here.
You're live
So-
and so on. Yep. Do you want to
So we're-
do the video again, or how are we
back
there?
on video. Yes, we are back on the video. So what has happened is that the plasmas become closer. So instead of being in row with a gap, now with your no gaps. So this is the state of matter, and this was the state of a plasma. But when it's in line, becomes a nano, and we call this one layer. This is called one layer, and this is called nano layers. So you have an equal gap distance with the same amount of energy, which these energies is dictated by the length of your arms to be yours. That's your space. We call one plasma. But they carry the same energy as when you are jam-packed to each other. And this is how the plasma in what we call plasmatic nano condition behaves. Atoms with a gap. And when there are equal gaps, then and the gap is, for example, 10 to the minus 9 meters, we call it a nano layer, which stands in its own layer at that distance from each other. But the energy inside it is the same. Your energy, when you are an arm gap between the friend, has not changed than when you are next to each other. You have less room to move, and any move you do affects their position too, because now you are shoulder to shoulder. But when you are at arm gap and you put your arms down, you can move, you can swing, you don't touch anybody. And if anybody running amongst you and you want to just let them go faster, you move a little bit to the left, to the right, there is no friction. And this is what we call freedom of magnetic field in the plasma condition. But the other point is, now in nano layering, you stack up instead of being in front or back of each other as well. So you have people next to you, in front of you, behind you, above you, and below you. And now layers stand floating on top of each other with the same amount of gap as you had with your friends in front of the back. Now if you can go sideways, they can put you vertically and open your arms. You have a friend who's an arm distance from the top and the below. It's very much, if you were to understand the behavior of nanomaterials, if you know the game called Knack. They have pieces and you have balls. We showed this before a few months ago when we were in the Sensano. I tried to bring those back and make you a nano layer that you can see exactly what it is physically as a toy. I hope it was a good explanation. If not, we'll try again another way.
No, thank you, Mr. Keshe, for enlightening me. Depending on what I would want from, if I wanted to reduce the gaps,
Yeah.
I
You
would
gotta
need,
find a push somewhere. You gotta find somebody to push your friends closer, or you have to push yourself closer to your friend. But
so I need
understand,
conditions. So So I need the necessary environmental conditions for that too.
Yeah, which means you need a guy who can push the other ones on the other end. It is very much, if you have ever played a tug rope game in the school, where everybody is distanced about a meter and there are two sides pulling the same rope to see who crosses the line which side. The gap is the same guy next to you, and whatever the other one does, the layer moves. Each one of you holding the rope at meter distance or half a meter distance is 1 nano space from each other. And then your motion, it depends on what the whole lot does. The only difference is the motion of you is your bending of the knees and your legs. Now the gap from the earth, from the next guy down is your legs, which next guy down is the earth.
I think that's a great analogy, and we should be able to generate an animation using little animated kids lining up and in layers and so on, and or maybe we could show ants or something like that doing it. I'm sure there's a way that our animators can work with that now that we have a visualization that you presented. It's good.
It's very much is the way it works, and the same as in the space reactors you're building. If you produce or reduce the gap between your ganses, the plasmas, dictates how much energy you're going to get out and how much you're going to release to the outside, that they concentrate to create lift or energy. The adults haven't understood this yet. When they understand this, then we have a very nice time.
Would it also tie in, I'm thinking of outstretched arms, and in terms of ice skaters, or a ballerina doing a spinning thing. When these arms are outstretched, they're at a certain speed. They pull their arms in and they rotate faster. Is that similar?
Yeah, very much so. But at the moment, we can explain this to children. They cannot rotate and have their arms open. Then you have a problem. They're going to do it to show the nanomaterials, and you're in problem in your school. They say, where have you learned it? Keshe Foundation. And then we are in problem. But
yeah, right.
So this is what they're going to do. But they understand the gap between them. That's where it is. I think we have to find a way to make physics fun. And the plasma technology is the reality. If we can make it fun, they grasp it. Because I know children teach their teachers what is wrong. And you find out that a lot of teachers fight it because then it means they have to learn a new thing.
Okay, along those lines, I was thinking a couple of days ago that it'd be great if we had a line or a product line of Keshe toys, or toys that illustrate or teach the principles behind the Magrev teaching and so on. We should be able to work on that. I'm sure there's people out there that can design things like that, and we can have them printed up with 3D printing or many different methods, and have them available for people as a product that could be fun to play with.
Right. Slowly catch a monkey. Today we open the university.
Yes, that's
enough
of a challenge for today.
Pardon?
That's enough of a challenge for today.
Next time we try to find open a toy factory.
Yes.
Spin-off.
Well, actually, I'm sure there'll be many spin-offs once this university gets a little more solidified. I mean, it's a natural thing.
We need the student. Today we had two very, what do you call it, very fresh students for the first time. They sat behind the desk after years like this. You know, one of the beautiful thing is when you look at the institute, the way the seats are set, all these people who come, scientists who come, and they've been there, most of them, a lot of them, leaders in their own fields, in their world of discipline of education. Now they come and sit behind the desk like children do, to learn from the beginning. It's very interesting. Today was first lesson, yes.
We forgot to congratulate.
We had only one student. I was Marco. Any other questions, or shall we close it for today?
No, thank you, Mr. Keshe. For me, it's done.
Yeah, I think we have enough to go on for the next to work with here.
I know Kevin wants to be a student to sit behind the desk in the first slot. Send your application form. We'll try to find you a seat.
Cool. Thank you. I'll do that for sure.
Thank you very much indeed. Thank you. Bye-bye.
Thanks for your time.
Thank you, Mr. Keshe.
Bye-bye. Bye-bye.
All right. Well, that seems to wrap up the 12th Kids Knowledge Seekers Workshop. Thank you, everybody, for attending.
Okay.